So welcome back. In this lesson, we're going to talk about a very important topic of reference counting. Reference counting is essentially the way that you assign your memories and how you decide whether a new variable or new property is going to have its own memory space or whether it is going to point to another memory space, and how often they do get allocated and how often they get released. Now, reference counting, specifically in Objective-C, is not the easiest thing to teach and to learn, but there are some very good practices that simplifies this for us. In this lesson, I will go through almost all of the reference counting strategies that are out there, and I will try to come up with some of the easiest ones for you so you can use them. Something you want to keep in mind is that you probably are not going to use any of these for a very, very long time. For the most part, you can actually stick to the default ways of doing things and nothing is going to go wrong. But then the time will come that you are doing something a little bit more complicated and you have objects that they have internal references to each other, and then you need to know how to deal with those. So with that in mind, let's go ahead into Xcode. And in Xcode, I'm going to start a new app. Command line tool, Objective-C. I'm going to call it ARC. And ARC stands for Automatic Reference Counting. That's like the closest thing you can find in Xcode for garbage collection, for finding what object is no more in use and has to be released, and what objects they have to stay in the stack because somebody is still accessing them. I'm going to call this one ARC. Let's say read write, because that's the first thing that we want to talk about. And of course, is Objective-C. Then, so here I'm going to go ahead and say I have a class at interface. Let's call it my class, and it has a superclass of NSObject. And in here, of course, I need to have my implementation of my class. And in my implementation, I have nothing because simply I just want to introduce some properties. The first property I'm going to make it like this. I'm going to say it is atomic. It is also read write, and it is also strong. And I'm going to call this one default string. So what does it mean? This is the default behavior of Objective-C. It means when you define any variables, by default they get to become atomic, read write, and strong. So theoretically, writing this line and writing this one are exactly the same thing. It will automatically would have those qualifiers added to it. I'm going to call this one auto default string. So that's the easiest thing. So we got that out of the way. Now, what is difficult, or not difficult, but what we need to discuss is, so what are these things? What do we do with them and how do we use them? Let's go ahead and get started with the most basic one, which is this one, read write. I'm going to say I have a property, and that property has only one qualifier called read write. And then I have the same thing. Once again, this is called my read write string. So this is read write string. And then I have another one which is read only string. And I'm sure you can imagine what happens now. If I go ahead and make two of these properties in my file anywhere in my .m, and I'm gonna say my class, my object is my class new, then I could go ahead and say my object dot read write becomes hello. But if I try the same thing with my read only, look what happens. It gives me an error saying that, hey, you cannot set anything to a read only property, simply because read only properties are meant to be only changed at an initialization level. So for that, you cannot change it anyway. So because of that behavior, we can only set the read-only variables using an ivar, and that means using the set read-only string, which is something that we often do when we want to do some internal calculations. So More of this will come in a few minutes when we're talking about iVars. But for now, let's say that for most everything, you probably want to use a read-write, which is a part of the default behavior. So let's keep that in mind, and let's move on to another example, which we're going to talk about atomicity of a variable. So for doing that, I'm actually going to go ahead and start a new project. Let me copy everything from here because you're going to need a lot of these things. I'm going to go in here and say command line tool arc atomicity objective C, and then in this one I'm going to paste everything. So here on the top, forget the default ones, we know what they are. You could add everything in the same project. For me, I'm trying to have everything in one screen. That's why I like it this way. So one of them becomes atomic, one of them becomes non-atomic. And if you remember, atomic is the default behavior. And of course, I'm going to change the names to atomic string and non-atomic string. So let's see what these two things are. I'm only going to write 2 keywords for each of these in the hopes that, that would kind of explain it for what's coming up. Atomic is multi-threaded and locked. Non-atomic is single-threaded and unlocked. Let's see what do these things mean. Atomicity essentially is about the way that something gets accessed. Imagine if you have 2 different threads or 3 different threads are trying to change a value of something. Maybe you have a thread that is your UI thread and you're seeing things, and then you have another thread which is trying to connect to your backend and read some information, and then you have another thread that you're doing some calculations. So it's very common to have multiple threads at all times. So in a situation where all these threads are trying to access the same value, it becomes a little bit unclear of which one is accessing it first, which one is writing it first, and when we are trying to read it back, which of the values we get access to. Now, in a situation where you have a variable which is atomic, it means every thread can simultaneously access it. It means every thread, before they access it, they will lock its value. So in the meantime, while they're doing something on it, if you try to access that one, you see the previous value, which is a good thing. It means you will get some value back. Your value will not be nil because that thread is doing something on it. The downside of it is you might not get the correct value. It might be that you're getting the value right before an operation and you're not seeing what is happening inside the operation. Now, in a non-atomic variable, what's happening is there's only one thread that can access a value at any given time, and it doesn't try to lock it. It just goes on and it starts changing the values of that variable, and the downside of it is obviously you might get a nil value. So let's see this in practice, and I should warn you that some of the code I'm going to write in here is a little bit advanced for us. We're going to see these in a few sections when we talk about threading and sessions, but for now we kind of need to just see them as a demonstration. Don't worry about the specific ways that they work. So in here I have my object, and I have my object dot atomic string, and I'm going to write both of them in one line saying is my non-atomic string, and they both have a, let's say, a default value. So by now we have an object that both of these strings are set to something, and we know if we print these, we're going to see essentially the same thing. So this next thing is going to be quite new for us, and that is how to start a new thread. So starting a thread is usually an operation that happens by something else, when you access to a network, or you might want to manually, run a thread to update your UI. But here I'm going to start a thread on my own. I'm going to say dispatch, and in the dispatch, I'm going to say dispatch async, and the one I want to use is dispatch get main, get global cube. And then for the identifier, I want to use the dispatch queue priority background, no flags. And here is the body of the code. So this piece of code essentially is going and starting a new thread for us. And when I start this new thread, I'm going to do this. I'm going to say both of these values, let's give them something else. Let's call it the second value. So that is second value. And then I'm going to go ahead and start another thread in here and say both of them, they get a third value. So what's happening? We have a default value that is our current value. Two other threads are accessing these values and are changing them to other things. And they're all happening simultaneously at the background level. So the very important question becomes, so what is the value in either of these two right now? So if I go in here and I say nslog, and I would say atomic is, and I would say my object dot atomic string, and I would copy that and say non-atomic is non-atomic string, we should see what's the result. So here, if I run this, when it shows up, now here we see that atomic is still default. So atomic is reading the value that it was there. Those other two threads haven't managed to change it. Non-atomic is the second value. So if I go ahead and say, well, let's go to one of these threads and change their priority to say high priority, and I run this one. Now my non-atomic value reflects the most recent update. It is, as you know, single threaded, it's not locked. It goes and says, well, finish this thread, finish that thread, finish that thread, and then give me the value. While my atomic string says, well, I'm just trying to get you the result, and the result I can find right away is whatever it was there. I'm not going to worry about those other threads. So there is some advantages to using either of the two, and the situation will come for you when you know that you have to use non-atomic. But for most everything, you can use atomic, which is the default behavior in Xcode anyway. So that was about the atomicity of a variable. Now let's move on to another topic. And that's a matter of whether an object is being copied or it is being assigned. So we'll see what that means in a second. Like the last time, I'm actually going to copy everything from here. I'm going to start a new project. This new project, I'm going to call it arg copy versus assign, Objective-C, of course. And bear with me as I paste this and I change a lot of stuff. So off the top, I don't have to worry about the atomic part anymore. I'm going to change one of them to copy, call it copied string, and then I'm going to change one of them to assign, and I'm going to call this one assigned string, and I'm going to change that. Perfect. And in here, I don't have any of those threading and whatnot. What I do have is that they both have one initial value. Let's call it copied string is assigned string, and I don't want them both to be looking at the same static value. I want it to be actually inside another variable. So I'm going to go ahead and say I have a ns mutable string that I'm going to call it value, which is ns mutable string, string by string, and that string says default. So the reason I want it to be inside an ns mutable string is because I want to change that value really soon. So I'm going to say both of these guys, they are value. So whether they are copied or assigned, whether their mode is copy or assign, they are going to be the same value of val, which is an ns mutable string. So the next piece is actually very easy. Once they're both assigned to val, I'm going to go ahead and say, well, val has actually had some stuff, append, and some new things. So as you can all imagine right now, the value inside the val is default, a space, and some new things. Now what happens if we print our copy the string and assign the string? So I'm going to say copy the string, assigned, and assigned is going to be assigned the string, and let's run this project. And when I execute it, we should see down there in my console that copied is still default, It doesn't have those extra bits of text, and assigned is having everything. So this is what it means. It means that copy, any variable of the type copy, whenever you assign them, whenever you initialize them, they make their own copy of the value and they place it in a new spot in the memory. While assign essentially keeps a pointer to that part, to whatever was value in there. Just so that we know assign is very similar to weak, and copy is very similar to a strong, and that's something we're going to see in the next example. What is the difference between these two guys? So to demonstrate the relationship between a strong and weak qualifiers, I'm actually going to go ahead and start a new project. And this one, I'm actually doing it in Swift simply because that's something that we use more often in Swift. I'm going to say arc a strong, weak, Swift. And in here is what we're going to do. I'm going to write an app that has a very basic user commenting relationship. So here, I'm going to go ahead and say, on the very top, I have a class called comment. Let me have another one, class. This one is user. So we have two classes so far. We have comment and we have user. So for comment, I have var text, which is going to be empty at the beginning. So that's the text body of the comment. I also have a user for it. So I have a var, I'm going to call it owner, and that's going to be a user. And that's essentially who has written that comment. Now, for a user itself, every user has a name, which by default is empty. And then every user also has a comment, which is going to be comment, of course. Now, in real life scenarios, this obviously would be an array of comments. But for now, I'm trying to simplify things, and I'm assuming one user can comment on one other user and vice versa. Nobody can comment on multiple different people. So that's that. And of course, I need to have an initializer. I need an init here, and I'm going to say imp name. And I think that's pretty much all I would need, because comment, I have to just start a new one. So that's easy. I'm going to go ahead and say self.name becomes input name. And I'm going to say self.comment becomes a new comment. So far we have two classes that each of them deals with something. One of them deals with having writing comments. The other one deals with holding on to all of our users. Now, the tricky thing in here is they both have a variable of each other's type within them, and that's somehow a common situation. You write your stuff in a way that they have data relationship between them, and we have to find a way to make sure that our retain count doesn't go beyond what it's meant to be. So here is how we're going to test this whole thing. I'm going to go ahead and say, let's make one user. Let's say my user. That's going to be a user of, and the only thing I have to give it is John. All right, so I have a user with the name John, and then I'm going to go ahead and print how many retain count I have for this user. So I'm going to go ahead and say print. In my print, I'm going to go ahead and say users count is, what is it? Here is something that is perhaps new for you, and that is get retain count. So I'm gonna say cf get retain count, and what do I want to get the count of? I want to get the count of this guy. So what it does is it gets how many copies of this are in the memory, and by default this should be 2 now, because it should be 1 for the actual variable and 1 for the ivar. So let's run this. And once our app runs, it says the users count is 2. So that's so far perfectly working the way we expected it. Now what happens when I do this? When I say my user dot comment, which is that variable in here, dot owner, which is this value in here, becomes my user. So theoretically, you could have a lot of situations where a user has commented on themselves, or two users or three users, they have inner commented on each other, and each of them is being used both as the guy who owns the comment as well as the guy who writes the comment. So now my user comment owner has become my user. And now let's go ahead and reprint this. User account now is 3. And here is the problem. The problem is that the next time we were trying to point to this user through this comment owner, not only we pointed at that, but also we copied it in a new space in our memory, which is really not a good thing. We ended up having more than one copy of my user, and that's being assigned for only this one. So to remedy that, I'm going to go ahead and say, well, it's a very simple fix. This owner, which is only going to be a pointer, has to be a weak link. If it's a weak link, it means like assign, don't copy. It means do not copy the value. So let's go ahead and see it. And now both counts are still 2, simply because here when we are setting that, we are not adding another count. And finally, in this lesson, we're going to talk about IVARs, or directly accessing variables. Let's see what they are. I'm going to start a new project in Xcode, Objective-C, and this is going to be IVARs, arc IVARs, Objective-C. And let's see, what do they mean? Imagine we have a class. So up here I have at interface, and let's call this a user class, and NS object, as you know, we don't know if we need anything else. And for it, I of course have at implementation, and that's going to be a user. And then I have some functions in here. I'm going to call this one sum function. Doesn't matter what it does. Sum function. Now, if you remember, whenever you had a situation like this and you had a property, add property, and that property was, for instance, NSString sum property, we could do two different things when we wanted to access that property. We could either say underscore sum property, that becomes hello, all right, or we could say self dot sum property, and that becomes hello. So what's the difference between these two? I'm actually going to write it within here, within the actual body of it. This here says directly accessing the variable, and this one here says accessing variable through the setter. So what is the difference between these two things? When you declare a property using the add property in Objective-C, it automatically does something that we call @synthesize. And what synthesize does is essentially sets the two variables, setter and getter. So what you don't know is, by default, this thing now has something called set sum property. There's actually a function in here called void set sum property. It's already being built, which receives a property and sets that. And if you use the dot operation, you're essentially accessing that method. If you use the underscore one, you access the variable directly. So in most cases, that doesn't really make a difference for you. You could use either or, simply because you don't care about what is within the body of the set. But if you wanted, you could manually do the setter. So I'm going to go ahead and add a new variable. I'm going to call it manual property. And for my manual property, I'm going to write both the setter and the getter myself. I'm going to go ahead and say void, and here is set manual property to something. And then I'm going to go ahead and say NSString, because it is of the type string. All right, manual property return. What should it return? It should return self dot manual property. So here is how I have essentially written both of these manually. And in the set, we should receive an input value that you can call it manual or you can call it new value. And then it of course has to say self.manual property has to become new value, or, and this is the only time that this happens, or you might not want to do that, or you might want to do something before you assign. For whatever reason, you might have a situation that you need to do something before you assign it. So that's essentially how these two will be different. You could get used to using either of them. I personally, for the most part, I use this system, accessing through the setter, simply because of this very fact. If I decide to change something in the setter, I can easily go ahead and do it. And if I had so many of these being applied like that, I can always just change something in the setter and they all will be affected by it. While if I use the IVAR, if I use the direct access, then I have to go to each of them and manually change that value. So that's about that. I'm gonna do a quick recap of everything that we did because it's kind of a lot of stuff in this one lesson. So here we did these things. We talked about atomic and non-atomic. If you remember, this was single threaded, might be nil. This one was multi-threaded, never nil, might be wrong, it might show you the wrong value. We talked about assign and copy, and we said in the assign points to a location in memory, copy essentially, I typed that wrong, points, copy essentially copies the information for itself. That's about that. Weak is a weak link existing as long as someone has connections to it. Strong is a strong link living for as long as the cycle lives. These wordings aren't exactly like that. For instance, weak is essentially saying maintain it as long as someone else has a strong relationship to it. But I'm trying to, I don't know, in my own way, I'm trying to simplify things a little bit. So that's about that. Different qualifiers for properties. For the most part, we stick to strong, and we also go for read write, and we also go for atomic. But there might be situations that you decide to change any of these. Like I said, you can live with the default values for now, and when the time comes, hopefully by then you will know yourself if you have to change one of those. With that in mind and this very long lesson finished, let's move on to our next lesson.